quick overview of the vocabulary. A few things you want to just make sure you understand here. A lot of things to understand. You're going to see here the different endings, and we really want to make sure we understand kind of how these are come about. So monomial is when you only have one term. A monomial is when you only have one term, just like monotheism is belief in one God. So then a polynomial is when you have many terms, many terms. And so polytheism would be belief in many gods. So there's really two more that I want to introduce as well. Just write them in here off to the side. We have what's called a binomial and a trinomial. So I think you can probably figure out what these mean, but everything here is based on the number of terms we have. So if it's a binomial, it has two terms, and if it's a trinomial, it has three terms. So we use this vocabulary to name some of our standard form polynomials. So one thing that's kind of confusing is that all of them are called polynomials. So it's sort of like we're all human, but then within human you have different groupings of people, right? You might have male and female. You might have different ethnicities of, you might be Italian, you might be Greek, you might be Nigerian, you might be from the United States, you might be from Ecuador, lots of different ways of classifying, but they all fall underneath human, right? So for us in this, these are all polynomials. So I'm going to underline that up here because these are all polynomials, but then we have more specific kinds like a monomial or a binomial or a trinomial. Anything more than three, we just call it a polynomial. So there's nothing for four terms and five terms. We just call it a polynomial. The next thing we want to talk about is the degree of a polynomial. And the degree of the polynomial basically comes from the exponent. So really what you want to look at is you want to look at the highest of all the exponents. The highest or the greatest, all right, basically the biggest of all the exponents. So if your biggest exponent is 5, then it has a degree of 5. If your biggest exponent is 2, then it has a degree of 2. All right. Now, the last thing, and this is a very important idea, is what does it mean to be in standard form? So it's sort of like I would never call, if my name is Matt Crouch, no one really comes up and says, "Hi, Crouch Matt." I mean, that's still technically my name, but it's just not in the right order. So we typically write a polynomial in a certain order, and we have a specific order that we do that in that's called standard form. So when we think about standard form, it's when your exponents, of each term are in a particular order. So when they go from the highest exponent to the lowest exponent. So highest to lowest. So if you have an exponent of 6, that would come before the term that has an exponent of 2 and 4. So it's making sure that they're in the correct order. We're going to practice that here in just a little bit. So getting something in standard form. Look at these right here. First thing is, can we add or subtract them? And then when we add or subtract them, we'll talk about what standard form looks like in just a second as well. So adding or subtracting is as simple as combining like terms. When we combine like terms, we look at the number. We look at that number and we simply add those numbers together, but we have to make sure that they are married to the same variable with the same exponent. So both of these are married, they're multiplied to x squared. So if they're both multiplied to x squared, that simply means that we have 3 plus 8, and they're both married to x squared. So that's a kind of a silly way of writing it. Oh, I'm so sorry. It's not 3 plus 8. It's 3 plus 5. So obviously the answer is going to be 8. But that 3 plus 5 comes together, and our term is simply 8x squared. Now I want you to notice something here. The x term did not change. There's no change here. There's no change in that exponent. A big mistake. A big mistake that people make. So you don't have to write this down unless you want to, so you don't make this mistake. But a big mistake that people make is they go, oh, 3x squared plus 5x squared is 8x to the fourth. No, 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 no. Right? Makes me cry, makes me angry there. The exponent stays the same. So if you want to add that on here as well, the exponent doesn't change, so stays the same. Add that to your notes. All right. So looking down at the second question here, don't overthink it. All we have there is we have to make sure they're like terms to begin with. So we look at their variables with their exponent. So x to the third and x to the second. Oh, right there. No longer are they like terms. I believe that's not what it says on your paper, though. I believe on your paper it's 4x to the third y minus x to the third y. All right. Either way, they have to have the same variable with the exponent, same variable with the exponent, and the same y. Y. So right here, we simply do 4 minus 1 is really what we're doing. The x to the third y stays the same. So my answer ends up being 3x to the third y. There you go. All right. So that's all about combining these like terms. Let's talk about some different, putting them in like terms and counting them up and determining their degree as well. So here, this is simply a number all by itself. So its degree is actually 0. Since it doesn't even have a variable, its degree is 0. And then here, it only has one term. It only has one term. So you might want to call this a monomial, but we actually have a different name for it as well. Because it's only a number, and because it's only a single number by itself, we call that a constant. That's called a constant. It's called a constant because a number can't change. There's no variable next to it, so it's going to stay constant. Let's look at our next one. Our next one has two terms, 5x and positive 9. So terms are separated by addition symbols and subtraction symbols. So terms are separated by addition and subtraction. So because, whoops, I did that wrong. I'm so sorry. So because that would be my number of terms, but what's our degree? Our degree is the fact that that's raised to an invisible 1, so our degree is simply 1. All right, so the way we would call this based on its number of terms, it has two terms, so this is a binomial. A binomial, since it has two terms. Next one has 1, 2, 3 terms. 1, 2, 3 terms, so 3 terms. And its highest exponent is a 2, so its degree is 2, has a degree of 2. And this has 3 terms, so this would be a trinomial. A trinomial. All right. Now we're back down to just one term, so that's called a monomial. Oops, misspelled that one. Okay, a monomial. But it's not constant. This is not constant because it has an x with it. So it would not be constant. What's the degree of this? The degree of this is our highest exponent, so our degree is 3. Last but not least, right here we have 1, 2, 3 terms. 3 terms, which makes it a trinomial. Trinomial. And then what's our highest exponent? Our highest exponent is this 4. So that's our degree. The degree of our polynomial is 4. All right, so we're going to do some practice problems as we keep moving forward.